it protects your web server from taking too much load. It also means that yeah, you can do things like geolocations. If you've got clients coming from different parts of the world, you can help redirect them to different places and basically sort of hide the fact that you're doing that via the APIM layer. It also breaks down in terms of features for simplification. It handles things like caching and quotas and limiting and logging, which are all things you can do within an API at the moment. But to be honest, if you've written caching or things like quotas, it can be really painful and quite a lot of work. And essentially, it's putting a whole bunch of sort of logic and features inside your API that don't really need to be there. And finally, there's some logging. It also generally, because we're pulling a lot of the functionality out of the API and putting it to another layer, it also means that the APIs are simpler. It reduces the amount of time it takes to implement functionality, and basically means improves things like testing and deployment, because you can do a small change to an API. You don't need to worry about the extra functionality and testing, regression testing, and those sorts of things. And another thing that I thought I'd put in that APIM does quite well, which is customer support. But again, it's for an enterprise organization like we are, it's probably not as relevant. But the Azure product has a lot of stuff around. If you were publishing your API, maybe open source or something, you wanted, there's a whole bunch of sort of ways of subscribing to it and getting documentation about the API and those sorts of things. So although that's part of it, it's really not that relevant for us. And the final section is decoration. So things like URL aliasing, it copes with implementing things like versioning in the URLs and those things very well. It handles the consolidation. So if you have different hosting facilities or different technologies being used for your API, it can mask that from the user. That's also really good for things like monitoring, reporting, just getting basic analytics on who's using your API, how they're using it, and where maybe some of the problems are appearing. Good. So the first thing I thought I'd start talking about really is API design, because generally I think it's important to make a really clear distinction about what your API is now going to do, because we're pulling functionality out of the API layer. You need to still keep a clear idea about what is the responsibility of an API. So when you're designing it, I generally think you need to make clear decisions on the layer's responsibility. So what is the API layer doing? What is the APIM layer doing? And also, what are you still delegating further up, to things like firewalls and DNSs and routers and those sorts of things? So making a clear definition, because we've got these distinct layers, it's really important to make sure that you're not doubling up. So if you're doing authentication on one layer, not sort of trying to do it too many places, because that will ultimately just confuse things and add complexity. And the general basic sort of rule to use is basically implement things as quickly, as early as you can, and the place that it's most easy. So if it's easiest to do it on a certain layer, then it's generally a good idea to do that. It's also nice if you can keep the API as simple and as specific as you can. So there's lots of talk at the moment about doing microservices, about reducing what APIs do, not having these large APIs that do everything. And again, I think APIM is a good tool to help. The other thing you may want to consider is that if you've got an API that's working with APIM, maybe you want to restrict who can get to that API, because you've got this layer in place. I think it's quite important if you have some sort of protection. So maybe you do some sort of thing to the API which only will accept requests that have come from the APIM, and you can do that either by passing a certificate or some sort of IP restriction or some other sort of authentication way, so that you know that every single request that's coming in is going via this APIM layer, because if you've got functionality there, you want to make sure that it's being used. And the final thing I would say is generally a good idea to use the sort of self-documenting stuff that's out there. Web API works very well with Swashbuckle, which is a framework which does Swagger, which basically produces an output in JSON form which documents the API. But there are other ones. OpenAPI is another common one. And generally this is a good idea, because it means that the APIM layer can ingest that and do a lot of the work for you. You don't have to manually go in and configure APIM to know everything about your API. It can extract it from that. So in terms of this demo, and also for the following stuff that we're going to do in the coming week, I've developed an API that I've just called Stuff. So basically, Stuff is it's a simple CRUD. There's a create, retrieve, update, delete API. It's hosted in Azure. It does some very basic validation on the model, and if there's something wrong with the model that's passed in, it returns a 400 bad request response. Anything that's good, it comes back with a 200 response, so you get a 201 if something's been created, a 200 if everything's okay. And I've also put in a couple of extra things, like if you ever ask for an ID which is a 404, it returns a 404 not found. So it's basically sort of mimicking a typical CRUD API. But the key thing is that there's no authentication or authorization at all. There's no caching. There's no idea of personalization. So there's no request is anything that's different from the client. It doesn't know anything about it. And the other thing is that there's no persistence. It's just complete junk data. I'm using a framework called AutoFixture, which is generally used for unit testing, which just generates data. So I'll show you in a minute. But basically, what comes back is complete rubbish. And the other thing, I haven't bothered to restrict the APIM, to request to only come to the APIM because I wanted to show you what the API looked like. But again, that would be a logical step to do. So in terms of what it looks like, we've got when you create a Visual Studio app service, it gives you this out of the box. So basically, this is Swagger, and Swagger is a standard in terms of XML that gets documented about an API. I'll show you what it actually looks like. Is this? It's a whole bunch of JSON, which when you look at it a bit more prettily. Sure.
Sharing that screen is sort of your face on the so people watching can't see that.
Oh, seriously?
They can hear you though.
Oh, that's going to be a complete nightmare.
There's a massive ball over, don't worry.
In case you wonder.
Ah, damn, it's quite late. Tell me that. Oh well.
Sorry, I didn't remember.
Anyway, okay, so you can see that's Swagger JSON. So basically, it explains all of the different methods. You can see the operations it supports, the content types, and also some breakdown about what the models look like. So it's not particularly useful to look at it that, but inside a Swagger UI, it gives you a demonstration about what this is. So you can see basically it even gives you a way of calling it. So if you wanted to do a quick request, you can request it for a given ID. You call it, and basically out comes the output. And as you can see, what I'm saying, it's just junk data. So the other thing to look at is, because they're all HTTP requests, you can also do things from Postman. So again, if we open up Postman, we can see we can do things like we can create some stuff where we pass in a whole bunch of the data. We send a request. It comes back with a 201. Okay, so it's just an API which, yeah, as you can see, there's a lot of rubbish in there, but essentially it's doing the functionality that we want for an API. Good. So let's go straight into it. So now I'm going to use this base API that I've got that's working and hosted inside Azure, and I'm going to configure it within inside APIM. Now, as often happens with Azure, I did a whole bunch of preparation for this, and then they've just come out really, really recently with some new preview views of it. So when you come to look at this in the week, you'll see they've got a whole bunch of new preview methods here, which I've been playing with a little bit this week, and it's good. It's definitely a step in the right direction, but there's been some, I've also had quite a bit of problems with it. So I think for now, I'm going to keep using the old way, which basically is a separate site that they set up called Publisher Portal. So if we go into this, you'll see a very similar sort of functionality is all exposed here. But, right. One thing that is really good for this, though, is the adding of an API. Great. Okay, so here we are. I've created one API already, but I'm going to add a new one based on these different things. And as I was saying before, it knows about different API standards. So open API is there. You could even import WSDL, SOAP envelopes. But because I've got a API that's hosted as an app service inside Azure, I'll pick this one. And so this is basically you set it up. And again, because it's inside Azure, it's smart enough to be able to know all the APIs that are hosted inside Azure, and this is the one for the stuff one that I can pick here. But obviously, if you didn't know that, you could enter in the URL of the API that you've got. We'll give it a name. And then the other important thing is the suffix. So as you can see down the bottom here, this is the same URL for all of the API stuff. For APIM, but obviously it's using a domain that Azure provides, but there'd be no reason why we couldn't do a CNAME record to that to have it be a bit more user friendly. But so for now, I'll do that, and I'll just call it my demo. So basically, what that's saying now is that this is going to be the URL that we'll give to clients to use, because it's going to be going through the APIM layer. we click create. It goes away, does the call to that Swagger JSON to get everything else, and it then extracts the different methods out of it. Yep. Cool. So that is literally all that we need to do. Now we can make the exact same calls to the APIM layer and see that it would work. So you can see here again, it's just still doing a request. Is that big enough? So I'll make it a little bit bigger. Okay, cool. So it's the APIM request. I need to put in my demo. And when we do a call here, the first thing we notice is that it's actually returning a 401 access denied. It's saying that the access is denied due to a missing subscription key. And that's because, and the reason I've done this is to show you, because this will be the same thing when you're using this week as well, is that by default, it automatically assumes that you're going to have a subscription key that APIM provides, which is basically its way of handling users and authorization. So the first thing you'll need to do is to turn that off. So basically, I've created a, I've created a product which basically has no protection at all, so it's just called anyone. So you just need to add the API to that one. Cool. So now we can do a postman request. Takes a little bit of while to synchronize, but it works. Right, I'm just going to stop at that point there. How are people feeling? Are people sort of getting the basic idea? I know I went to that quite quickly. I'm just really conscious that I've got quite a lot of stuff to do, but I think I'm going to stop at various points to sort of make sure people are generally happy with what I've been doing. If you know, reasonably happy with the basic sort of setup. All I've really done is I've just created an API inside APIM. I've created some basic mapping and between the APIM layer and the actual one. So if you look at it here, you can see here all we've done really is just taken this URL and it's now become this one. Okay, cool. So to sort of summarize that, basically the way you configure an API is you create the API by selecting the APIM and the alias that you want to use. You add any operations, which because we were using Swagger, it was able to automatically import those. Then we assign a product, which in this case, we assigned a product, which meant that there was no user required. And the next thing to do is policies. So policies for APIM is basically the functionality, the rules that you implement to manipulate the requests coming in. And so what I'm going to do now is basically go through some sort of typical policies that you might want to implement and show you how you go about doing that.
Excuse me, when you assign the product, how is I didn't get the relationship with the authorization?
Yeah, fair enough. Cool. Okay, well, so basically if I go here, what comes by default with the Azure product is this idea of having users. So essentially, you could do it though that you created users here and inside under users, and it's basically every user gets a subscription to a number of products. And so, for example, if you go into a product, so we've created one here for anyone, and inside the anyone product, so that means no one can see it without knowing the URL. But essentially, you add APIs to a product. So the idea is that you have a subscription to a product, and the product can have any number of APIs underneath it. So it's just sort of a subscription model that they're using. Well, product is a grouping of APIs, and then you have users who subscribe to a product. I mean, and I can see what they do it that way because it makes sense if you're trying to sort of do publish your API to a number of people. But at our sort of level, we don't want to create thousands of users inside their user thing. So as we'll get into it later, we'll be able to see actually by bypassing their subscription model, we can actually implement our own one, which is a bit more flexible and a bit more sort of enterprise level. But so, yeah, so the main thing you need to do is just to make sure that you add the API that you're talking about to this anyone product, because essentially that's. If you go into the settings, you can see that that's just been, I've just unticked this subscription, which means that provide a key for every request that you do. Yeah, anything else that's... Okay, cool, I'll keep moving. Great. So, creating policies, great. So if we look at the request that we did here before, one of the first sort of things that when you look at it, if you look at the headers that are coming back, you can see that IIS by default, when it's an ASP.NET website anyway, returns some headers, which I've never really understood why it does it, but essentially if I was a hacker looking at trying to hack into an API, one of the first things I would do is I'd have a look at these, so you instantly get some idea about how the website's, how the API is being run. You get told the version of ASP.NET it's using and the fact that it's being powered by that. So one sort of simple thing which you can do is to remove these headers, because basically it's giving away security information that you don't need to give away. And again, there is a way of doing that inside Web API. I think there's some settings you have to add into the to the setup of Web API to say don't return these. But it's really simple through a policy inside APIM to just turn that off. So go back here. So I am going to switch to the demo API now, because I've basically got all these set up. So you go into policies, you select the API we're talking about, which in this case is demo. Do operations actually for all the APIs that you've got configured. So this is every single API that's configured. We can go into just the demo one, and that's for any request for this API, or we can even go into the individual operations as well and set up policies for that. So basically, it's sort of a hierarchy of policies that get implemented. So in terms of this one, I want to do it for every single request that goes into demo.
This APIM portal that you were showing, go back to that.
Sorry. Yep.
Here, this is, I know it is hosted on Azure, but is that the sort of website you created, or Azure will provide this?
No, this is all. So this is the portal that just comes with Azure, and all I've done is I've just selected the API management service, and then once you come into that, you can use these preview runs. I'll show you these in a minute, but I just click the publisher portal here, and that's brought you into it. And basically, all they've done with these previews is pulled the functionality that's in the publisher portal into the main portal. Okay, cool, great. So policies inside APIM. I mean, this is probably one of my biggest criticisms about it. It's quite clunky. Like basically, it's a whole bunch of XML. And then you can actually, within the XML, do code itself. So essentially, inside the policy, you have an inbound section, which is the request coming in. The back end, which is what happens to it after it's gone to the API itself. And then the outbound. So basically, it's what happens once a response comes back. So in order to get rid of these policies, all I'm going to do is let's comment out these ones. You can see these are just the XML tags, but basically what we're saying is we want to set the header, and we want to take the one where it's got X ASP.NET version, and the existing action is to delete it. And they've tried to give you some sort of help, like you can basically see these policy statements over here. So these are essentially templates that you have. So you can see, you can go here, you put the cursor where you need it to be, and then you say set header, and you click the button, and it essentially puts in that same thing for you. Right, so essentially all we're going to do is we've said that we're going to remove these headers from this zone. So we save it. It goes back to this edit free mode, and then we go back to Postman. We do a request. It takes a little while to synchronize. Calling the right URL would help. So you can see essentially now those headers have been removed. And this is all we're doing for when we're creating policies. We're just putting in little bits of XML which do some sort of manipulation either to the request coming in or to the response coming out to change the behavior of the API. So another thing that might be we might want to do is when we come to actually add a stuff item. Again, for a post request, we don't generally put in an ID. We're doing a post to this. We've added in the body the request that we want to do. So when we send the request, it's come back with a 201 to show it's been created, but it's come back with a header, a location header, which is still pointing at the old website, because essentially that call has gone through to the API. It's done what it normally does and returned back a location header that is a reference back to the object that's been created. And so it's doing that one. So another thing we might want to do is to tweak that URL to, because we want to change it to not be the API's endpoint, we want it to be APIM's one. It's reasonably easy to do. Come back to our policy for the demo. We could go into the create the post operation itself, but because you can create on a post and a put, it makes sense to just put it higher up. So basically we're saying whenever we have a location header, we want to replace it. So again, we're using the same tag, the set header, but this is introducing for the first time the code. So essentially, it's just like Razor, really. So essentially, we're saying set the header for location. We want to override this time. So if whatever value's there at the moment is being changed by whatever we've done, and then we have a value. And then from here on, it's just Razor code. So it's just like Razor. We've got an @ symbol and then a round bracket if we're just returning the value, whereas we can use curly brackets if we want to do more complicated things. And then it also gives you a whole bunch of objects. Essentially, this context object is always going to be there, and it allows you to interrogate things. In this case, we're going to interrogate the context response. So the response that's been returned back from the API is going to be in the context response, and it's just an HTTP response message. And so we can interrogate the headers, and we say, right, get the value for the location parameter, or the default, which is an empty string. So we get that value, and then we replace the API endpoint with one that we want it to do, which is the APIM endpoint. So essentially all it's going to do is look for the location header and just do a straight string replacement and return that in the response coming back. Cool. So then when we hit send, we can see straight away it's changed it. So again, it's masking the fact what the endpoint of the actual API is altogether. And as far as the user is concerned, it's just the same URL that it's got. Okay, so how are people feeling about that? It's like I say, it's weird that it's XML and then there's sort of code underneath it. Like it's quite an odd way of doing it, but actually once you sort of get your head around it, it is actually really flexible. And so the trick really comes to be knowing all these different objects. And one good thing is that Microsoft has documented these quite well. And essentially you have all the basic sort of .NET framework stuff that you have normally. So, you know, all the systems libraries. It's also got things like JSON.NET and stuff, so you can manipulate JSON or, you know, XML as well. So essentially the same sort of stuff that you want there. Right. So we've done calling the API. We've removed the subscription restriction, i.e. we've added it to that product for anyone. We've removed some response headers, and we've re-aliased the location response header. Next thing that would be quite interesting to do is to add a basic sort of cache. So one thing that we've got, if we do a get to the endpoint for stuffs, we do a request, it takes a really long time to come back with that response. Essentially, you can see here, Postman's telling us it took 5.1 seconds to do that request. And that's because into the Stuff API, I've actually built in a delay so that it takes a long time. So this might be a good candidate if we had a request that was taking a really long time to come back. And maybe it's because there's some indexing that are wrong, or something about the nature of building up this request response takes a long time. And if it makes sense to do caching, it might be something that we would put into the APIM layer. So again, it's reasonably straightforward to add basic cache to things. So again, when we do a cache, it's actually to a specific operation. So if we go into the get all stuff, which is the one that relates to that operation, we come in here. Again, you can use the these templated things that come here, but essentially what we're doing is this. So what this is saying is create a cache lookup that these parameters are just if you've got users set up that are in specific developer groups and things, but they're required fields, so I hate to put them in as false. And then it's basically saying look at the accept and the accept character set headers, and if that's different, create a separate cache item. So basically, that's doing a quick lookup based on the request that's come in. And the reason you want to separate by the accept or the accepted character set is that could be that it's a different request, like it wanted an XML or as opposed to JSON, or they wanted it to be in UTF-8 or ASCII or something. So you need it to be separate for that. So that's basically, your request is going to come in, it's going to do a check to see if the cache has got that response already, and if it has, it returns it. And then the other thing that you obviously need to add is once it's built up the response, so we're now in the output section, we want to store that cache, and we store it for, say, 600 seconds, which is 10 minutes. So basically, that's if it goes all the way through, doesn't find anything in the cache, goes to the API, it comes out, then we want to cache that response. Yep. So if we save that, you go back to Postman. When we do the request, the first one obviously is still slow because it's not in the cache, so it's had to go to the API and comes back in 5 seconds. But then subsequent calls after that, hasn't synchronized quickly, but the next one is a lot quicker, 66 milliseconds. So you can see it's not slowed down because it's not even going to the API at all. It's just handling it inside. A really good way of reducing the amount of load and work that your API is doing, particularly in this case where it made sense to cache it. So that's a nice bit of functionality that we've added just by adding one policy into that sort of logic. What else are we going to do? Then the final thing I'll talk about in terms of the basic policies is another good thing that they've got, because it's an Azure product, they've got nice integration with some of the other resources that you have. In fact, there's a nice one which can automatically call an event hub. So seems like quite a nice thing to do is to actually add some logging. So every single request coming in and out will just push onto an event hub so that we can do with it whatever we want. So again, we want that at the all of the API level. So we go to the higher level here. And essentially what we want to do is, because we want to link the request and the response together, we're going to create a variable called logging message ID. And again, just using the Razor, we're just using GUID, new GUID to generate that. The variables are another tag that means that you can then access them at any point. So we're going to set this variable at the beginning, and then when we come to with the response, we want to pull that out again and use that as well. So you can see you can create here this context.variables and then a name that you set in the name field there. So all we're doing for this is we're saying, right, build up a string that's separated by a pipe. And say, right, have a field that says it's request. We're going to have that GUID that we created, which is unique for the request and response. The time of the request. The context object also has an API, which is essentially gives you information about how you set up the API inside APIM. So that in this case is going to be demo, because this is the API we're working with. It's going to log the original URL and then the method that they called. So no sensitive information is being stored. We're not storing anything about the user or anything, but it's just going to give us a basic idea about the request. And then on the outbound one, as it's coming out, we'll do a similar thing where we'll also log to an event hub. So I should have said this ID just uniquely identifies the event hub we're talking about. Build up another string, this time saying it's a response using the same ID, name of the API, the response status code, so whether it was 200 or 201, the reason, and this the cache control, because they'll come in later, but it'll tell us whether it was a cached response or not. So again, just by doing that and saving that, now every single request that comes in is going to add that string onto an event hub for the request and the response. And I'll show you later, but basically I've just got an Azure function, which is just looking at that event hub and chucking any request that comes into it onto it into some table storage. So essentially this is going to log every single request that comes into the APIM and store some basic information about it.
How do you set the name of event hub? How do you connect to your special?
I mean, so this is uniquely identified. I've sort of glossed over this a little bit because you have to do an API call to set this up. I mean, I can show you so separately, but basically, yeah, they haven't done a way within the portal to do that. You had to go do an API call to the management API itself to say, right, these are the credentials. But essentially, you just name an ID and you give it, you know, the connection string to the event hub, and so that it knows how to do that. So I mean, I could show you that later, but I mean, yeah, basically it's just a way of saying, like, this is the event hub I want to talk to. Cool.
Does setting up logging have any impact on performance?
Well, that's a good thing because it's just going to an event hub. You're only slowed down by putting something onto the hub. You're not waiting for it to then be taken off the event hub, logged to the table storage, and coming back. And there's other policies which do things like send a one-way request, so you know, send off and forget. So if you wanted to call another API, say that you had for some other sort of task, you could just send the request off, and it keeps going asynchronously. So you're not being slowed down at all. It's a good point asking about how long things take, because it's one of the things people worry about with an API layer is what's taking the time. You know, am I slowing down my user's response? So that's maybe a good time to go into the portal for doing this. So basically, we'll go to the new one because it's actually quite a nice feature. So if you go into this, you can see, again, they've sort of done a way of sort of explaining it a bit better. You can see there's this flow about there's the front end, then it goes into the inbound, goes into the back end, outbound, and then comes out again. But they've added this really nice thing, which is a test. So essentially, if you pick your response like this one, and you go to the test, it's a bit like the Swaggy API where you can actually put in a value that you want to do, add some extra headers which tell you about the trace, and you hit send, and you get the response that's come back, and you can see it's been a 200 response with some output, but you also get this trace, and essentially this is a complete breakdown of exactly what the APIM is doing at each stage, so you can see how long things take. So basically that took 0.6 of a millisecond, so really, really fast to show what came in. So you get a full breakdown of everything coming into it. You can see that it did, I don't know exactly what these things are, but so it's done a lookup for the API itself, and that's taken 0.018 of a millisecond. It's then called the backend service, and it's told you how long it's taken to do that. You can see that's where we're setting the variable, you know, where we got the GUID, and it's assigned it to that variable, all taking 0.005 of a millisecond. Called the event hub in 0.018 of a millisecond. So again, these are really nice quick times. Tells you how long it took on the back end. So that's where it actually calls the API. So the API itself took half a second to run. Again, you get a full breakdown of what that is. And if there's any error or anything that's gone wrong at this point, it'll show you, and you actually get the full stack trace about what's gone wrong. So it's a really good tool if you're suddenly just getting an error back or a 500 or something, you can actually go into this debugging tool and actually see what's going wrong at each point. So cool. So that's that. Right. So we've done that. Cool. So at this point, I think it's quite a good point to go into the authentication authorization, because essentially we've now got an API that's running and able to do things, but it's only on a for the entire API stage. We really need for it to be really useful to actually introduce this concept of personalization, of actually knowing who the user is and giving them different behavior based on what they're allowed to do and what they're allowed to see. So I'm going to spend a little bit of time talking about authentication and authorization. Essentially, what the problem is and how it solves it is we have a client who is either going to be an individual site user on a website, there could be a process, or could be another API that's calling our API. And we have a service, which is the API itself that we're writing, that we're responsible for. And what you want is for the client to be able to call the service acting as itself or on behalf of something else. So if you have a user who's on a site, if you think about it, the site itself can call the API, but if they're calling the API as another user, they need a way of impersonating that user. And essentially the way a lot of the industry is doing it now is using an authentication service. So it's essentially remove the whole idea of authentication and authorization away from being within the API itself and using an auth service. And it uses these tokens or JWTs or JOTs to store the information inside them. Essentially, you don't want your client or your service to be aware or take responsibility for authentication or authorization. You want this to be done by your auth service. And you also don't want to have to keep calling your auth service. So basically, you get a token and it lives for a certain period of time. And once you've got that, you can keep using it. You don't need to keep going back to authenticate or keep going back to authorize. So to give you a quick breakdown about what JOTs are, again, I'm sure a lot of you know this already, but I think it's good to just quickly go over it. Basically, it's an open industry standard, FC 7519, which represents claims between two parties. Essentially what it is just a blob of JSON which is signed, which that's the important thing, is that the person who creates the token signs it in a way that means that you know who's created it. And they create claims, and there's some standard claims which should be there in all JOT tokens, but then you can also do custom defined claims as well. And the whole point about a JOT is that it can be decoded by anyone. So anyone can take a token and see what's inside the token. And it can also be verified by anyone who has a certain key. So if you get given a token, as long as you have the key of the issuer, you can check that that token was really created by that issuer. So that's really important, because if someone gives you a token that says, I am this person, you want to make sure that they're a trusted person. It's not that some other person is pretending they're someone else. And then the other key thing is that only an issuer can create tokens. So tokens basically are very easy for anyone to use, but are very hard to create. And then on top of all of that, there's an open auth standard, and there's open ID Connect and how it uses it. And basically, it's a whole bunch of sort of standards which cover how you generate the JOTs. And there's a whole bunch of flows about how you obtain the token. And like I said, it's really important and really necessary, but also it's pretty dull and pretty boring. But the important thing for you, if you're trying to authenticate and authorize your API, you don't need to worry about how that token is generated. You just need to know that it's going to be coming in and then using it. So actually, for this part of it, we don't need to worry, and we can actually use tools to generate these tokens for us. And so we can sort of remove that whole complexity about logging. How do you identify who you are? How do you generate those tokens and everything? So basically, it breaks down into two ways. The authentication is called an identity token. So identity token proves who the user is, and whether that's the individual user who's using a website or the process or the API, it just says who they are. And there's some basic claims about that user which tells you who they are. And then the authorization is handled by an access token, which identifies what the user can do for a specific audience. And in terms of authorization talk, the audience is the API that who uses it. So this is the standard claim for a JOT token. Oops. You can see ISS, it's a standard JSON, and basically what they break down is to the ISS is the issuer, so this is the person who created the token. The issued at, the IAT, is when the token was issued, and it uses Unix timestamps, which is just the number of seconds from the 1st of January 1970, and expires, so that's when it expires. So that's really good. So within every single token, you know who created it, when it was created, and when it stops being relevant. And if you ever get a token that's expired, you can't trust it anymore because things may have changed. The audience is who it's intended for. So in our case, it's our API. So some identifier for the API itself. And then the subject is the user, who the token is about, and whether that's an individual user or a service. And then in terms of custom claims, again, basically because it's just JSON, you can use whatever sort of format you like, but generally it's agreed that they should be a key value pair. The key should have some, should be a URI because it means it's unique and is some way of sort of giving you some idea about where it's come from. And the key thing is that it should mean something to the audience. So when you get an access token that has this, there should be things in there that that the audience says, right, I know I need to look for these certain claims in order to make some decisions about it.
So we move from, sorry,
yep,
authentication into authorization. In this instance.
So
yeah, the claim we've identified who that individual is, surely with like the previous slide, but here we're getting a little bit more granular. Yeah,
exactly. So
what can the user do? What do I think this user can do?
Exactly. So an identity token comes from the authorization service, which tells you who this user is. And then typically how it works is that you say you get your access token from your identity token. So you've got the identity token that says you're David Dunkley, and then you go back to your authorization service and says, I'm David Dunkley and I want an access token for the demo API. And then it goes away and says, first of all, checks that the identity token is valid and they really are who they say they are. And then they go to the auth service and then pull back all of the claims that are relevant just for the demo API and puts them into an access token. So in terms of authorization for an API, you're really only worried about access tokens because that's been specific to your audience, to your API that you're working with. Yeah. Cool. Great. So we've got our access token generated, so we know who the user is and we've got specific claims for it. So the first thing we want to do is we want to make sure that they pass the token. So generally what you do with access tokens is you pass them in the authorization header of the request. So what we'd like to be able to do inside the header of a post is have the authorization, and again we tend to pass them as bearer tokens, but we want to be able to put the jot token in here, and so it's passed in the request and then we can use it. How are we going time, Simon, is it? Okay. I mean, again, like, if we go too far over, we can just pick this up again tomorrow. But, yeah, sure. Okay. So in terms of the API management, if we want to go, so again, we want to do this for all of the requests coming into the demo. And essentially what we want to do is we want to make sure that they've passed in authorization header. So this essentially is the switch statement. You see, it's just quite clunky how you do it, but basically we're saying in the inbound, we're going to check the condition. We're looking at the request header, we're checking the authorization thing, and we want to make sure that it starts with bearer. And if it doesn't begin with that, then we're going to return a response straight away to say it's a 401, it's unauthorized. There's a sort of a standard which says you should basically return another header in the response that says the fact that you're looking for a bearer token. We're also just going to return in the body itself a bit of information about what went wrong. And essentially that's all we're going to do. So with this policy in place, if you don't call with a bearer token, you're not going to get any further than that. So if we save that, we don't send that for now. So instantly we start getting a 4 request, and we can see that came back from that one. Whereas if we return that with some sort of token, it does go through. Okay. So the next thing we want to do is when we get our access token, we need to validate it. We need to check that it really is who we say it is. So there's a site here which basically builds tokens. So you can see it adds on these ones by default. We don't need them. So you can see the same ones we were talking about before. So the issuer, the IoT, the audience, and that. So we want to set it up so that the issuer is that's the audience, just using the URL that we have for that one. We want to do the issuer, which is who's issued the token. Again, we're just going to use the domain for this builder. Okay. So you can see this is using these claims. There's no additional claims at the moment. That's what the token looks like. And all it does is it just creates a big blob, which is the token. If we put into our response header like that, so that's now coming in. And again, is there a policy which allows you to validate token? And the thing we need is, this is the key that you need to be able to validate a jot. You need to have that key. And the other slightly complicated thing is that it's base 64 encoded. Just need to quickly encode that key. So what this policy is going to do is it's going to take the authorization header and check that that token was really generated by the person we thought it was. So this is an example about if you haven't got the syntax quite right, it complains. So I'm doing something wrong. Yeah. So now, if we send a request, it works. But there are obviously other claims as well that we want to check. We want to check that that it came from the issuer, for example. So again, there's more policy claims that you do to check that the issuer was who it says they were. Audience. That one for now. Okay, so this is saying that it needs to have that key, but it also needs to have an audience. So it needs to be a token that's been generated for the API that we're talking, and it needs to have come from this place. If we save that, and if we, for example, issue a token where it's intended for, I don't know, a different audience, so my demo, for example, if we generate the token, pass it in, so it's saying it's authorized because it's not a valid token, but if we put it back to being the audience of what we said it is, send it, it does work. So essentially we've now created a token and we're checking that the access token that comes in is being issued by the person that we trust and that's been intended for the API that we are. That's probably quite a sensible place to stop, do you think? I mean, how are people finding it?
I think so far it makes sense that a lot of APIs you would probably like policies and lots of ones, which obviously takes a lot of time.
I mean, what I'm planning to do is do a few more things, which now that we've created the token in a way of identifying an individual user, we can then do specific things for that user. Like we can, for example, use properties claims about that user to change the behavior, but we can also do things like caching if they have student claims which allow them to cache or can't, we can do those sorts of things. And we can also change the response coming out. Again, if the user doesn't get to see the full response, we can remove that from the response as part of this thing. So I mean, I think I might edit it a little bit for tomorrow, but basically you can see it's a bit clunky the way you're sort of editing XML and then putting in razor code and stuff is a little bit weird, but essentially it's it gives you a lot of functionality once you've sort of got your head around it.
These XMLs, they have a basic template, right? That you can, or you have to add them.
I mean, they have, like, they've got these things here which sort of put in bits of XML that you need to manipulate, but I think what will probably happen in the future is that they'll then sort of do a layer over the top of this which will edit this XML underneath it, because as part of the work we're doing, we looked at a couple of other products, and that's essentially what they've done. It's still just building up this stuff underneath, but the tools will get a little bit better and a bit nicer for editing it. And to be fair, they've started to try and do that with some of the preview stuff that is there, but yeah, it's still not quite there. Cool. Okay, well, yeah, we'll pick it up tomorrow. I think, yeah, I'll cut down a little bit what I do, because I don't want to keep talking for the entire next session as well. Sure. Basically, we'll look at redacting some body content. So based on the user, we'll remove some of the stuff coming out of the response. We'll maybe look at doing some rate limiting stuff. So you can actually, based on the user, you can say, well, they can only make 1 request a minute or 10 requests a day, or you can sort of reduce how they use it. Because again, it's this whole idea of like productizing your API. You can actually implement those sorts of things down to the individual user level by putting in claims. Yeah, I mean, that's essentially it. And then we'll quickly go over acceptance testing, because once you've basically implemented all this sort of stuff, you can then write acceptance tests to actually test that your functionality of the APIM layer is working as well as the API. So I've written a project which does acceptance tests where we actually build up a token that you pass in as part of the acceptance test, so you can test that if you don't have access to a certain level of functionality, you get the 401 response come back. Then also a quick bit about release management. So it's basically how you do changes. Essentially, it's all done for a Git repository underneath all of this. So all the changes that we're doing inside the portal, you can then deploy as a commit into a Git repository, and you can then like view that. And I've actually pushed all the changes that we're making as we go along. I'll create a commit, and then we'll be able to see how we can actually push that to stash as well. So we get a full list. And we'll actually be able to see that as part of a release, if you done some changes to the APIM layer, you can actually do the link to the commit that you've created for that as well. So if once you've done a deployment and you've deployed the changes to APIM, if something goes wrong, you'll be able to see exactly what's changed. So that's quite important. Yeah, and that's essentially it. And then I'll sneak preview into to what's coming up for the next few sessions. But yeah, like I say, I'll cut it down a little bit because I think I've covered the main sort of ground. But yeah, I'm really conscious that I'm going through it quite quickly. I'm also really conscious that I've been doing a lot of the stuff for the last month. It's probably a lot more familiar to me than it is to you guys. But yeah, it's fine. I think for the next 2 sessions, I think it's really important that you guys actually get involved and actually start to play with something yourself. And you really only get to really get familiar with it if you're doing it that way. Cool. Okay. Well, thanks very much for coming. And yeah, we'll pick it up again tomorrow.
So,